he's got a bunch of notebooks that were written in the version that we basically instantiated for the boot camp. The new notebook, like as of like a week ago, we'll be able to read those old versions of the notebook files, and it will say when you first open it up, I noticed this is an older version, I've just converted it. I hope that's okay, and that should be all right. There's a chance that if you've been pulling over from GitHub the notebook, or just IPython in general, and you haven't done it recently, that it won't recognize these old notebooks. But you should be probably okay. All right.
Okay. Yeah, so there's a lot of files to grab. It's all under lectures, and it's just one zip file. And then the homework has also been posted, but you don't have to worry about that yet. I'll be giving some more information about that later and showing a little bit of what you're going to be doing with the homework. It should be fun. So today's lecture is about how to interact first with computers in Python, and then in the second part of the lecture I'll be talking about how to interact with hardware and people. And so it's just a cartoon here of Python, and then it's got arms grafted on to show that now it can communicate, and then R2-D2 is the computer, obviously, because it's a computer. So in this first part of lecture today, I'm going to first be talking about how to talk with web servers and websites, and the important Python modules we're going to be using are the built-in stuff, URLlib, URLlib2, FTplib, HTTPlib, and HTTPlib2. However, we're also going to be doing some parsing of HTML with HTML5lib and Beautiful Soup, and you probably don't have Beautiful Soup right now, so just run the command. Well, I guess the cursor doesn't work. So just run the command easy install Beautiful Soup 4, and you should be able to get that and have access to it within your Python installation.
Or pip install.
Oh yeah, either way. This will be very useful later on for the breakout, so you should definitely get it, and hopefully you'll be persuaded that it's way more awesome than doing it by hand. And I'll show you parsing stuff later on. Also, in this first part of the lecture, I'll be talking about transmission control protocol, TCP, and creating sockets and clients, socket servers and clients so that you can send information across that type of connection, either within the same computer or across a network. And then we're going to have the breakout exercise, which is to teach you about how to automate access to websites and then parse using Beautiful Soup or whatever you want, really, the information into more workable formats within Python. And that'll actually have to do with collecting baseball statistics. And then for the final part of the first part of today's lecture, I'll be talking about XML RPC servers and clients, which you should pay a lot of attention to because that's going to be part of the homework assignment, is creating an XML RPC server client pair. And I think it's one of the best ways to communicate between two computers both running Python, and hopefully I can convince you of that as well. Notably, it exposes functions on the server side that the client can call, which are executed on the server side. And that has some significant benefits if your client, for example, is on a really slow computer. Okay, so before I get started into websites and web servers, I just want to make sure that everybody's on the same page about how computers talk to each other. So in transmission control protocol, you have IP sockets, and most of the network communication is on TCP across the local area network, or as you go onto the internet. And there's also UDP, which we're not going to talk about too much, but you can support that in Python as well. And here's a diagram to basically show how data is sent. And I think the most important part to look at, there we go, is this is kind of like a schematic diagram of how you send information through TCP from one computer to another. And it's addressed by the MAC address, and then the IP address, and then the port number, and then the actual information. Okay? So what we're only going to be seeing really is the IP address and the port number in our examples today. You don't have to worry too much about the MAC address, but the MAC address is kind of like a more stable identification for a computer. So whereas IP addresses can be static, most commonly they're dynamic. So when you see DHCP, that's dynamic IP addresses. And so, for example, AirBears assigns you a dynamic IP address. But if you have a hardline Ethernet connection and you set your computer to use a static IP address, then you can always know what your IP address is, which is very useful, for example, if you wanted to connect to it from the outside network. You'll know the address to get into it by. So I think that's pretty much all you're going to have to know for today's lecture. We're also going to be seeing a lot of this data here, and this can be almost anything. In our examples, in the next few slides, it's going to be HTML code, essentially. Okay, so you use a URL, you guys probably know this, to access a website and retrieve information. But why would you want to do this? Well, if you want to mine data, which is what we're going to do in the breakout exercise, you want to be able to easily access websites and pull down the data. You kind of did that when you were naming bears, if you did the first homework assignment, homework 0. And I will demonstrate in an example how we do that a little bit more efficiently now that we know more. You can use web address URLs to submit information to another system, to the server from your client. Or if you wrote the server, obviously, you could support that. And access web services. And so if you wanted to have a server do some crunching for you, you can do that through a web address through the interactions I'm going to be describing in the next few slides. And in particular, this is the type of thing that XML-RPC servers support more easily, let's say. More simply for you to code up than having to actually write a full web server type thing. OK, so here I'm going to start talking about the nitty-gritties of the modules that we're going to be using early on. And they are essentially the built-in URL lib and URL lib2, which are the libraries for URL access. And URL lib is kind of like the earlier one. It was written with not as higher functionality as URL lib2, which is better for more complex interactions and can handle authentication, cookies, and some more higher level things. And I'll talk about authentication, not so much cookies, in the examples in the notebooks. And they basically make calls to HTTP-lib and HTTP-lib2. They import those modules within them. And for example, this is just at the bottom. Where did my cursor go? URL lib open URL and URL lib2 open URL, you should use the second version. That's what we'll be doing today. But they are both still there, and eventually this one will be eliminated. And I just wanted to make you aware of that. So the doc strings, this is just to make sure that we have that information out there. You can read it if you want to, just by typing help in IPython, but we'll skip through this type of stuff. The most important thing that I want to highlight, obviously, because I've highlighted it, is that it returns a file-like object. So when we read a URL address with these libraries, we're going to get a Python structure that is handled like a file. So you read it like a file, and you have to close it out if you want to be proper to close it like a file. OK, so let's get to some examples. Okay. Yes. So talking to computers, so I kind of numbered them to try and make it easy. So talking to computers, which is number 1, and this is going to be what we're going to be focusing on until we get to the client-server stuff, which is 2 and 3. You probably already saw that. So this is just a super simple web page access. And I'm going to import URL lib2, and then define a URL, which is just the string for some web page, and then open it with URL lib2 open URL. And then, as I mentioned, the response here is a file-like object, and then I can read it and store the data in what I'm calling HTML, and then close it out because we're proper and we like to close things so that we don't screw with memory too much. And then I'm only printing the first 300 characters because it's really long. And you can run it, and there it is. So are there any questions with that? It's
Do you want to maybe open up that in a different tab, the actual URL, and then do
yeah.
And then show the source?
Oh, to verify. We can prove to you that that's actually what it shows. So this is what it looks like, rendered in a browser. And then if you check out the source, where is it? View source. you could see, so for example, the first 300 of these probably cuts off around here is what we had here. So title, neuroscience information framework, and then you see that same title in the source in Safari, right there. So you should be aware, I guess I'll say this right now, many websites hide some of what their stuff's doing, and it's not explicit in the HTML. So if you've got Flash or some JavaScript plugins, there can be information that you can read in the browser which are not really present in the HTML, and you won't be able to access that, at least not through this urllib2 OpenURL function. We're not going to worry too much about that. Those are kind of difficult to script anyway. Okay, so let's get back to the presentation. So I want to give a brief overview of Hypertext Transfer Protocol. And basically, when we transmit information over TCP/IP sockets, and the standard is port 80. So when urllib2 is calling out for this, it's doing it over port 80 by default. And if you wanted to create a TCP/IP socket server or client, and just stay away from port 80, because your web browser is going to be looking to use that. And there are basically reserved ports, and you can find lists of them. And of course, you can modify them on your computer, but other servers and clients expect to use specific, port numbers for specific services sometimes. So generally, if you're above 5,000 and you can arbitrarily define them, you're going to be OK. And so all the examples I'll be using later are 5,000 and up for port numbers. HTTP is used to transmit resources, and so resources can be files, query results, or server-side script output. And here's a Here's a diagram basically showing how the HTTP request is formatted and schematically transmitted from the client to the server. So the client basically sends a request with some header information and then the body. And then obviously the server reads it and then sends a response with response header information and then a response body. The two most used request methods are GET and POST. So I'm going to just move on to the next slide where we talk about GET and POST. And this is going to define basically, so it's going to define how you append additional information onto the URL. So what we did in that first example was just access a web page. But if we wanted to access a web page and send up additional information, for example, to fill out a form, if we wanted to make a query or have it run something with information that the client provides, you're going to do that either through GET or POST. So GET is the most common and the most generic form of sending up query information. And it is basically writing the query variables into the URL. And I'll show you that explicitly in the next example. It is a little bit less safe than POST, and so it's mostly just used if you want to retrieve a static file. If you want to be very good about submitting a query, you would use POST, which takes the variables, and in a Python dictionary, it encodes them, and when you call URL open, you add it as a parameter, optional keyword argument, and that sends it along with the URL request and the client request to send it to the server. And the server can then know to parse that, and it knows it's getting a POST request. So let's just see it in action here. So here is the GET request. We'll go through that one first. I am defining a dictionary data, and then I'm filling it with keyword data pairs. So in this case, what I'm going to be doing essentially is accessing the astrophysical data system, which is a way that astronomers can access information about published papers. They collect papers. So let's look up the abstracts for papers that our professor has written. So we'll add in the author, Josh Bloom, as a dictionary, and then we call this URL encode function. And that basically creates a string called URL values. And we'll take a look at that after we run this, and we'll see what that contains. But for now, you just have to know that it encodes author and Bloom, comma, Josh S, so that it can be properly formatted in the URL. And then we define the base URL, and then we append after a question mark URL values. OK, so let's just run it. And this takes a little bit because it actually runs a query for us. So the astrophysical data system is saying, OK, given this information, let me return. And there's a lot of abstracts that it is returning. And we're only showing, of course, the first 300 pages, 300 characters. There aren't 300 pages. I think there's 272 abstracts when I checked. So let's create, and let's check out what URL values stored. OK, and then if we look at the full URL, we can see that it took author equals Bloom, and then this is a code for a comma. Or where is this space? Yeah, I think it's, yeah. And then plus Josh S. And so the ads.harvard.edu, when it gets this URL, it doesn't matter where it gets it from. The URL has encoded in it the query information. So it knows to run the query with this. And we'll see how this is different from post. And you can just go to a web browser, type this exact URL in, and you'll get the same query. So let's just. And so can we scroll over? Yeah, we see here.
Static, that gets are usually for static pages, but this is not static, it's dynamic.
Right. So
the way I think about it is, get is you're pulling over information, and post is sort of pushing information into a server. I think of those, and both of those could be used in either direction. But get, I usually think of, give me what I want based on this query. Post is, here's some information that you're going to want to store. And in the end, they may be storing this query anyway.
That's a good point. So obviously there's limitations to the type of and the quantity of information that you can put up in get, because it's got to go into essentially the address bar. And in post, you don't quite have those same limitations. It's more flexible. So we get the same web page, and everything seems to work. So hopefully that's. So any questions on get so far?
So is this sort of a standardized interface, the URL plus question mark plus
Yes.
name encoded like that?
Yes.
Or did you happen to know that that's how the
No. The question mark, that's standardized.
Okay.
So you can go to any website that has a form where they support get queries, and what differentiates the base URL from the parameters for the query is the question mark. And so in the HTML of that web page, there's a thing called author. And if we just go to the base page.
So if you have to kind of know something about what that form is going to ask for, right?
Yes.
Is there a way to pull the keywords from the query?
Yeah. So yeah, if you didn't know what you were doing already, you could download the HTML, and it would be, I guess, kind of really tricky to write a function that could parse the HTML and figure out for all websites.
Well, for
Yeah.
generic websites.
But
you can show them the form data now, right?
yeah. So here's the places where you can put in author.
So it's that text area that names the variable, and then when you actually are clicking submit, you're basically instructing a get query that you're submitting to the website, and it's returning back something else to you.
Mm-hmm.
So if you go to Google and you want to pull over a query, they don't have, I think, the question mark. I think they use Q equals. Every
They do have
website
the
has a
question
slightly
mark.
different way. Do they now?
There's a question mark right here.
I mean, the question mark is just the part, yeah, everything after the question mark are the variables. So there is a Q there
There's a
that
Q
the
equals,
NASA
okay,
thing.
And then here's the query information that I typed in.
So, and the reason why you're doing the URL encode, this is the important thing, is that if you wanted to query what's up with a question mark, the encoding needs to take care of
Yes.
that question mark so it doesn't look like another question. And if you were making a query on somewhere in there,
So this %3f is the URL code for a question mark.
right. And then if you've got non-traditional, non-ASCII characters, it'll encode that for you. So it's just a safe way of sending data.
Okay, so now let's look at it from the post perspective. So things are very similar, except that now, whereas before we did URL encode and we just stored it as this URL values, here we're going to do it as params. I guess it doesn't really matter what it's named. And when you give it to urllib2.urlopen as an optional keyword argument, it then knows to send it as a post request using those params. And actually, we're doing the exact same query, just in a different method. And it'll return the exact same response. Except, I believe there was one difference in that the HTML that's generated by the server actually encodes the full URL. And so you'll see here we have the question mark. Where'd that go? Yeah. Here we have the question mark after and then the encoded information in the get. And then down here, it's not in the URL anymore. So we don't see that in this line here. But the information, the post information has been sent when it was called in urlopen. They both take dictionaries for form entries. So this could have been year or for example, journal name, things like that. And you could have appended to any sort of information you wanted for the query. Okay. So there's also web servers out there that are going to ask for authentication. And by authentication, I mean usernames and passwords to make sure that you are permitted to view the content. And Python urllib2 supports this as well. And it does it by defining this. I don't have a. It hides my cursor on some slides. I don't know why. Well, so this is an example of how you would do it using a realm at example.com and a username and a password. And it's basically just these few lines. It's pretty simple. You append, you create build opener with the auth handler, where auth handler has the realm and the base domain, as well as your given username and password. And then when you call open on the opener, it sends on the authentication information. And so hopefully, I mean, you've probably encountered websites like this before, and this is how you can do it if you wanted to script it, and you had a username already approved for that website.
What's the realm again?
So a domain can have multiple different sections of it with different users. And so the realm is the one that you are trying to sign into.
Do you have an example page that you can share?
I don't have an example for this.
So this is different, by the way, than like if you go to
The one
a
that-
page
I mean,
that says what's your login name.
it
your password,
basically
it's
just-
in the form. If you encounter that, you actually have to essentially fill out the form and then send it to a post or to a get, and then retrieve back the information, which would be the next page. This is one where you want to.
So this is the type of thing it would be. So if I wanted to download data from the telescopes, I'd have to sign in. And it's already stored it in my keychain. But that's the type of thing it pops up. And it depends on your browser.
The gray box.
But how do I know what realm I'm signing up to?
It says it at the top.
Yes, so that box says the realm. We did that. Oh, okay, so and then also form-based authentication, which is similar. A little bit more complex in that you have to use the dictionary to encode the username and the password. But this is just an example, and you can keep this and hopefully refer back to it if ever in the future. It won't be in the breakout, but if, for example, you wanted to go to a website that had data that was restricted based on subscribers, and you wanted to mine from it, and you had subscription authentication information, look to these slides to give you just some pointers on how to do it quickly. Okay. So the next thing I want to show you is file transfer protocol library. And this is a more common way to access data mining. So if a server or if a group of people or a company wants to just throw up a lot of data but they don't want to make it easily accessible in a browser. They don't really care to. They just want to make it accessible to people with computers easily. They'll do it oftentimes through an FTP server. And what's a little funny about the internet is that now there's a lot of FTP servers that were created and are still out there, and many of them require anonymous, or many of them require some sort of authentication. Many of them are just open for anybody to use. And so in the example here, we're going to connect to a Penn State University anonymous FTP, which is just allowing us to connect to it. And I found this one by looking up anonymous FTPs. And we're going to basically just demonstrate some of the ways that you would navigate around the FTP server and retrieve a file. So let me put the line above there. And we can do ftp.dir, which returns, so this is like the ls command you would have in a Linux or a Unix system. And so I think it's mostly inherited from DOS. But this lists all of the files and directories in the top level directory of ftp.cac.psu.edu. And login, if you needed to use authentication, you would make it in this login call. You would have a username equals and a password equals. But we didn't have to do it because they don't really care. It's just a guest, and they're fine with it. So we logged in, and then I've already checked it out a little bit, and I know that there's some interesting things under pub /folkmusic/sheet music. So let's change directory into there. What? Oh. Wow.
Sorry.
Well, there's a lot of weird stuff on this one. And then we can list all the sheet music. And that's just using the ftp.dir command. And then to retrieve a file, it's pretty simple. Retrieve binary, and then retr to retrieve, and then the name of the file. And then we want to save it in Python, so we're writing it to music.jpg, because we're downloading a JPEG file. And this is just one that I picked randomly, so we can show that.
So you give it a method?
Give it. I do. There's a couple different ways you can do it. This is a simple way to do it within one line. And then just to show you what the big size H6. And then we can display it. So we downloaded some sheet music from this FTP server. And obviously this is just a trivial example, but if you wanted to download lots of data files, this would be a much easier way to script it, you can imagine, as opposed to accessing different URL pages and then having to parse the HTML each time and hoping that it's always the same. This is direct access, essentially, to the directory structure of a server through Python.
So would you have to parse the file in the directory, or do you do like a mget star to get everything in the directory?
Well, that's what ftp.dir returns.
Yeah, well, it gives you a list of files, not all the files themselves. So let's say you wanted to get all the sheet music all in one go. Would you have to parse that and then write it through all the files?
I'm not sure. So you want to be able to replace rights of man with a star. That won't work as it's written here because you'd be writing out one giant JPEG, and I don't know how it would handle it.
But I don't think it's going to work either. Can you even do that with normal FTP? If you do like an mget.
mget, yeah, mget works.
I don't know if it's got an mget.
So if you can also connect to the same FTP server through your OS. So that's how you would do it. As you would browse with a web browser, you could connect to this through just connect to server on Mac is just like Command K, I think. Yeah, and so you could type in this. Oh. Guest connect. It's a bit slow, but here we are. And we can go into pub, and we can go into sheet music. Now, what was it? Folk music, right? Yeah. And then you can see the exact same things. I'm sure it's perfectly fine. I'm sure there's also a way to get a lot of weird things from anonymous FTP servers. Anyway.
So I don't see in FTP the ability to do multiple.
Yeah,
parse the thing.
Okay, so we cover FTP. Yeah, that's good. And then just here again is the sheet music. So the next part of the lecture is to talk about HTML. And
FTP list, is that like a built-in?
yeah, that's part of the standard distribution.
Is there like an SFTP list?
Oh, I don't know. I didn't look into that.
I don't think that it's not, if there is, it's not in the standard library. I mean, SFTP is a lot more specific. Yeah. Terminco, yeah, that's.
So before we get into parsing of HTML in the breakout assignment, I wanted to give everybody just a basic introduction to HTML to give some example code so you can understand what it looks like. And I'm sorry if this is a review for some people, but I definitely didn't know this until I started doing science research. So hopefully some people will need this stuff. So HTML is hypertext markup language, and it's the code in which web pages are written. When we were doing view source earlier, that was showing the HTML. And as you can see, it's often very long and confusing if you don't know what you're looking at. So it consists of tags surrounded by angled brackets. And so tags tell you what type of data is following, and then it has the data within the tags. An HTML document has a hierarchy enforced by the ordering and nesting of tags, kind of like a tree with branches. And this is a very small hello world in HTML. The line 1 there, do I have a cursor? I don't have a cursor. Line 1 is just saying what type of HTML it is, and it's the most basic type. And then we start the file with the tag HTML, and we close it on line 9. And then we create a header, or a head tag, giving it a title, which is hello HTML, and that is in a browser that's actually on the top of the frame. So maybe I can show you easily. So this is where the title goes. So where my cursor is here, even though it says it here as well. I guess it would say it also in the tab if you had tabs open. But the title information is displayed here in the actual browser, not so much in the web page as in the GUI of the browser. Okay. And then the body has the information, and P is for, I think, paragraph. We're just creating a line of text in this HTML page. And if you were to show this, it would just say, hello HTML on the top of the browser GUI, and then hello world in standard font size in the actual web page. And then we close it out, and we're done. And just for completion, here are some examples. If you want to check it out, you click on these links, and these are some good examples of more complex HTML code, kind of introducing you to the different types of tags and tables in the data. Here is some example code which is more complicated. No cursor. But basically, the benefit of doing it like this is it's color-coded. So you can see where the tags start, and those are blue. And in the tags within the brackets, there's also some additional information. For example, where it says observation or object ID on line 11, that is labeling a query form entry. So observation or object ID is information that the client can provide. And even though it's given this explicit name, observation or object ID, as displayed on the web page, as it is stored on the server and as it should be accessed on the client, is called this this string parenthesis, quote in underscore 1. So that's short for input 1 when I wrote this up. And that means that if you had the question mark followed by the parameter name and then the form entry information, the parameter name would be in underscore 1. So when you're looking at source code for queries, look for those sorts of parameter names, not necessarily what it displays, but what it calls it on the internal side of the website. And here at the bottom, I believe starting at line 41, is also a very basic table. And so you can see that started with tr to begin the table. Yeah, line 34 is where it defines the table columns, and then tr is the table row. here's what the page actually looks like, which is rendered from that source. You can see the form information at the top and then the table beginning at the bottom. It's nice. What's nice about this is that it's just straight HTML. There's no JavaScript or Flash type stuff going on here. So everything that you see here rendered is encoded here in the HTML. All right.
So just to come back to the question somebody had earlier about SFTP.
Okay. Yeah.
There's something called Paramico, and that's actually in the NTOS distribution, so you should all have that later.
IPython actually uses that for that if you want to forward a client over SSH, basically you can connect to a remote kernel over SSH and have a local GUI front end for it. I don't think that's currently supported. Oh no, yeah, I think if you connect to no, it may be, yeah, maybe.
Okay, so the next part of the lecture is to talk about HTML parsing. So now that we kind of have an idea of what it looks like to the human eye, we can then take advantage of Python modules, which will take what's essentially a huge file-like object or a really long string and parse it by using these tags to expose the information to you in Python in a more reasonable and accessible format. And the built-in library for this with Python is HTML5lib. And it's a parser designed to be compatible with existing HTML in the wild and implements well-defined error recovery, et cetera, et cetera. So how would we do this? OK, this is very simple. So I'll just walk it through here in Keynote, and then I'll show you some more elaborate examples in the notebook. So we make our imports of urllib2 and urllib, as well as HTML5lib, and access our web page just as we have earlier, read it, and then we parse it just by calling html5lib.parse. And we're using a tree builder called SimpleTree, and there's a bunch of different options for that keyword argument. And you can change the type of essentially parsing that you're doing for whatever you're more familiar with, or if you know different ways, whatever exposes things more easily in the application that you're intending it for. And so doc is an object that's now in SimpleTree format. And as I said, HTML5lib also supports other formats, and some examples are Minidom, Element Tree, LXML, and Beautiful Soup tree formats. LXML in particular is good for creating well-formed HTML and XML. I'm going to be discussing in the examples Beautiful Soup. And we'll get to that after a couple of cartoons. So read these and then chuckle. The one on the left reminds me of the beginning of Magnolia, I believe. Is that with Tom Cruise? Yeah. That may not be very well.
One of the important points here in the previous slides is that many HTML documents that you might pull over are not actually valid HTML or valid XML. It's really hard to comply exactly with the right standard, and so oftentimes you'll pull something over, and if you try to parse it with something that's being incredibly strict, you will just fail. It'll say, you forgot to close this tag. So validating XML or HTML is a real big, huge pain. Typically what you really just want is the data. And one of the nice things about HTML5lib and Beautiful Soup is that they actually kind of figure out what somebody meant to do. So if they see a tag not closed and they see it something else open that shouldn't be open, they'll say, oh, that person probably meant to close the tag. So they clean up and they make beautiful the documents that are actually pretty ugly in a really amazing way. If you spent time having to deal with these types of documents, this stuff which is coming, only in the last few years is really quite amazing.
All right. So Beautiful Soup is the one that we're going to be going into a little bit more in depth, and hopefully you all downloaded it, as I asked you to at the beginning of the lecture, and it should be all accessible to you now. And I'll show you how to import that and start using it. It provides methods and Pythonic idioms that make it easy to navigate, search, and modify the parsed tree. So to the notebook, because we can learn by doing. Here we go. So first, we're just going to access this web page calling Big Huge Labs, which is one we'll be returning to a bit later as well, just because it's a very cleanly written HTML, easy to understand. So we're using it as an example. So we connect to it, and then we'll import from BS4 Beautiful Soup. And then all we have to do to parse it is run Beautiful Soup on the HTML and then save it as an object. And then soup has a bunch of functions attached to it that we can then call. And so we're going to find all the forms on this web page. And so there they are. And let's navigate to the web page just so you can see what it looks like. It is super simple. So there. It's just a form. And actually what you would do is, we'll get to this a little bit later, you can type in words and it will give you synonyms, antonyms, and rhymes. But what's cool about this later on is some of the APIs that it exposes. But for now, let's just worry about the HTML. That's what it looks like. And this is the form that is encoded in the source of that HTML. And so it's called input form. And it uses method get, for example. And it's got a size of 40, which defines, of course, how long this text entry box is, things like that. So we just parsed the HTML, which admittedly is really simple, but it was very easy to find a form, for example. So next, why don't we find all the links? And links are encoded in HTML generally by tags with an A in it. So where it's A, href, and then the link comes. So we can parse it. And for each link, we can print each link. And if you look, Big Huge Thesaurus, blog post, story plot, those are all on here. So this is a link, Big Huge Thesaurus, and then blog post, story plot, and then there's an about, API, privacy sign in, and then a contact information. And when we go back here, we get all that information here as well as different links that were parsed out of the HTML. OK. So here is hopefully a cooler example to show you how easy it could have been to download all those names for naming bears. So if you looked at the solutions, I used this website called listofbabynames.org, and it had essentially 26 pages with different URLs where the pages are just by alphabetical. So it was .org/ and then the letter, and then _boys.htm, or for girls, it was _girls.htm. And so we know a priori all 26 web pages, or 52 if you want to do both boys and girls, that you're going to be accessing. So we can loop through all the letters and access each page individually, download the HTML, as we would normally with URL open, and then parse it with Beautiful Soup, and I'm going to find all the listed items in there. So items is going to be a list of all the items that Beautiful Soup parses for us. And then I had to do a little bit of human thinking, looking at the source, to know that if there's not an A in the tag, that it is therefore a name of a baby in the way that they formatted their HTML here. So I can store all those and then print them out. So let's run it. And we're going to access 26 web pages, one after the other. Is anybody else running this? Maybe I should be the only one running it. Because I don't know how strong their support server is.
It doesn't have a lot of baby names. What if I want to name my
It's got 5,400.
If I want to name my kid Birdie, is that in there? I'll just check.
These are validated as ones your kid won't be picked on too much at school. So, well, we just downloaded 5,300. OK, so in what, 30 seconds, we just got all the names that you maybe struggled for a little bit of time doing the homework. And then to be cute, we can then, and to demonstrate that all of them were actually downloaded, I can create names ad nauseum, right? Just basically saying, OK. So that's mostly just motivation to say, hey, look, Beautiful Soup is awesome. Or parsing in general of HTML makes it a lot easier to work with. because this was so simple to run, and it was kind of simple to write, and it'll save you time in the long run if you have to be parsing so many web pages to just figure out the patterns and then script it like this. Your breakout exercise is going to be doing a lot more of this, a little bit more in depth, and we'll be getting to that in a few minutes, so you have that to look forward to. But the next topic, I believe, is TCP/IP sockets and servers. So quickly, an internet socket is an endpoint, and then sometimes you have, you have an API that goes over the TCP/IP protocol stack, and it's basically just a mechanism for delivering incoming data packets to the appropriate application process or thread, which is defined, you'll see, by the port number. So the server says, I'm going to send this out from whatever IP address I have over a port number that you give me when you write the server. And the client has to know, I'm going to connect to this IP address, and I have to already know the port number to be looking for. So let's go to the notebook. And this time, I'm going to have two of them side by side so that we can see both the server and the client. So if you can do that similarly, that'll be useful because you'll be able to see when the server is busy and then the client can access it, and it's a little bit simpler instead of having it hidden in the background somewhere. So let's talk about the server first, because you have to have the server before you can write the client. You have to know what you're going to be doing. So to create a TCP/IP server, we first have to open a socket. So we define the socket, and AF_net and sockstream, these are the accepted defaults. This is telling the type of TCP protocol to use as opposed to UDP, and the type of data packet to send. These are the more common ones. They work fine. I'm not going to spend too much time going into other types. Just use these if you don't know what to do. And then we define a host and a port, and by giving it the host as a blank string, it just knows to look at localhost. And port I'll define as 5000. If you jump ahead and you start playing with this and you get the error where it says port is already in use, just change the port number. Sometimes the OS will keep that port occupied longer than you're using it just to be safe. And so if you don't close it out properly, if you have to interrupt the process in Python, then that port will remain reserved by the OS for a period of time later. So just don't worry about it. Just change the port number for now. So once we create the socket, we then bind it with the host and the port information, and then we can start listening, which is to just say open the port, and then accept incoming connections. So then, when it gets a connection, it will print out client is connected at an address where the client, it knows the address of the client when it gets the connection. Yeah, it's the IP address, I'm sorry. So you see down. So the printout, and the printout doesn't work too well in the notebook, but if you were to run this in a terminal, you'd see it first print out client is at, and then you would wait. You would wait indefinitely until client sends a command. And in this case, when I ran it first, the client asked for the time. And so very simply, we wanted in this server to have some functionality. And the functionality is respond with how do you do if the command is hello, and respond with the current system time if the command is time, and response with it was nice hearing from you if the command is goodbye. And then once we get the response, once we get the data and then send the response, when we send it by with connection.send response, and then we close out, this is very important to close out your socket at the end, because that's part of what goes into the OS reserving the port number. Okay, so let's start up this, and now it's just running. And it hasn't printed out anything because the way IPython works, it stores all the printouts and then displays it at the end. But you can see that it's busy up here in the corner. And here we can walk through our very simple client. And so just import, do we even need sys? Oh yeah, I don't think we need sys. So just import socket, and then in the same way as we defined it in the server, we're going to create a socket with the same parameters for AFNet and SockStream for the data type and the TCP protocol type. And here, host is again going to be the local host. But you can imagine that if you were on a local area network and you wanted to talk from one computer to another, you put in the actual IP address. And this also works over the internet as long as you have static IP at the server side.
Sorry, did that mean, so can you give not the IP address, but the name of the host?
Oh, the URL? Oh, like, yes. Yeah, so if you link it, I believe it will
So it'll go to like
figure, it'll go to the,
DNS lookup.
yeah.
Yeah. Nice. I mean, the DNS lookup has to work on your machine, of course. It's not going to, it won't work like magic.
Okay.
So it'll use whatever lookup facility you have.
So in this client, we're just going to say hello, and then we're going to send the command. And here, data equals s.receive. This s.receive receiving on the socket says wait and read up to 100 bytes. And because I've written the server, I know we're not going to be sending 100 bytes. We're going to be sending a lot less than that. So it's OK to limit it to that. But if you wanted to write a way to transfer files over TCP, you would be wise, you don't have to, but you'd be wise to loop over it and say, while there is still data, read the next kilobyte or read the next 100 kilobytes or something like that, and then append it to whatever data structure you're creating in Python to create the final data file. But here we're just reading, we can read just once because it's so small, and then print out the information. So let's run it. And there, it works. And then over here you can see that the server has terminated because this server just runs once. And in the next, you can see, well, we might give one that runs indefinitely. But for now, let's run it again. And you can see we get the address already in use. So the OS is still reserving that port number, so we'll just change it, which is perfectly fine. And then instead of saying hello, we'll ask for the time. Just to kind of, I want to prove to you that it's running in real time. And then bam, we get the 2:22 p.m. 3:22 p.m. 3:22 p.m. We didn't human readable time. OK. And then the server exits out again. So let's demonstrate how to create a server that works until you kill it. And it's basically you define, and this is a simple way to do it, an echo request handler, which is part of socket server module. And you give it a base request handler. And basically in here, you create, when it handles a request, you read the data from the request. And then you, depending on what the data is, you can send a response based on how you want to code it up. So here I'm supporting hello and time, using the same thing as before, replying with how do you do, and responding with the system time. And then you send the response. And then when you create the server, just link it to, giving it the port number here, which is 5002, which is good because it's incremented again, and the TCP, the IP address, which is localhost again, and give it echo request handler, which is this class. So this class essentially contains the server, or contains the instructions for the server, and then when we instantiate the server, it knows what to do. And then server.serveForever serves it forever. So now this is busy, and this will just run until we interrupt the Python kernel. And then down here, I've written it again. So let's ask what the time is. And we can ask what the time is again. And so it is incrementing in time because the server is running forever, and we can run the client as much as we want. And we can run clients of different systems as long as we have the right IP address and the right port. This can be running from anywhere else connecting to the same server. So you could unplug your laptop, move somewhere else, connect to the server, run it again, depending on, doesn't matter, dynamic IP address, your client can be anywhere, and this will work. So this is a great way to transmit information or just send simple commands back and forth between two systems. And let me just, hello. Yeah.
Are we going to ask them to make a Turing test?
This wouldn't work from off campus, right? There's a fiber.
Yeah, so it depends on what's on the server in that case. I don't know. It depends on your setup on campus. It will not work over air bears, likely, because air bears is going to be blocking ports, arbitrary ports. Okay. So when people set up public or kind of unrestricted Wi-Fi networks, they will, if they're smart, they'll block ports other than like email or web browsing or common ones.
You can easily just create a SSH tunnel from your computer to the other computer, and then you could more or less map a local port to the remote port.
So to kill this, I'm going to have to interrupt. Sorry, Python. And then also, if you're running this in a terminal, which is pretty standard, don't just run it in a terminal. Run it in a screen. So screen is a program which can basically have a terminal running when the window's not actually open. Screen. Yeah. SCREEN. And it basically creates for you hidden terminals that you can then access and list and then have them running commands even when you even when you close that individual terminal. So if the terminal program were to crash, screen would still be running this in the background somewhere. Or in case you just don't want to clutter up your desktop with it and not have to worry about it anymore. So I use that commonly for when I have to run these types of servers indefinitely. Okay. So let me just get it tooled up here. I believe the next, how much more do we have until the breakout? We're almost at the breakout. Yeah, so we did that. Okay, we're at the breakout. Great. When we get back from the breakout, I'll be talking about XML RPC servers, but just know that that's a little bit cooler than TCP/IP, and it'll be on your homework. But for now, here's the breakout instructions. So I want you to go to this website and take a look at it. It is hosted by ESPN. It basically lists New York Yankees batting statistics. And I want you to take a look at the HTML source code and see if you can kind of make some sense of it just by eye at first. I would recommend do a search based on a player name and see where that shows up, and see, looking at the web browser, the row in that table that contains his information. You can see also how that is encoded in the HTML. And then I want you to write a function or any type of script in Python to parse that HTML into a usable list or dictionary or any type of structure you want to use, really, that makes sense to you, where you contain the player's name and then their statistics. And then once you do all this data mining, you can answer the question of all the players with at least one at-bat, what was the median batting average? So you can imagine that this would be hard to do by hand writing down individually or copy and pasting from the web browser. But if you write a Python script, you can just collect all those batting averages. And then you're also going to have to see the number of at-bats, because some people have 0 at-bats on the New York Yankees, and some people have a lot of at-bats. And so only worry about 2011, the 2011 season for now. If you are super advanced, and you can do this in a very short period of time, there's additional instructions on later slides which you can take a look at. But I'll leave these up, and this is the most important part for you to do. So get cracking, and I'll come around and answer questions if you have any. Don't look at the solutions yet. I gave you the solutions, but give it an honest effort first. Okay, and we're back. So I have up here now the solutions that I wrote to the breakout, and it's not important that you read all of them. They're just there for you to have, so you can look at it in the future for the other pages of the assignment. But basically, this first page of the solutions addresses 1 and 2, where we make functions. To first, all you got to do is retrieve the HTML. So this is really just defining the first thing I showed you in the notebook today for URL-lib2, URL-open, just grabbing the HTML. And then that'll be called a lot throughout the rest of the program. For example, to get a team's season statistics, first we grab the HTML, and then we parse it with Beautiful Soup. And I just do a search on TD, and then create this items, which is a list, an iterable. And then for each item in items, define it as items n. And then if player _/_/id/ is in there, which is just something I found by looking at the source code, that always precedes the player's name. And so if that is in this item, then that is a row of the table that we care about. So we parse that row by figuring out the player's first name and the player's last name just by reading the row in the HTML. And we know that this parses where item is the string that represents the whole row. If we split it first on spaces and then go back to, right, and then split it on, I guess that's a greater than sign, you can go back 1, we'll get the player's first name, and similar stuff will give you the last name. And then to define the whole player's name, we'll put them together. And then the rest of the row contains the number data. So you can strip that to create the rest of the data, and then parse it one at a time for one of the 17 numbers in there. And then we just create a list of lists. Then the final thing is just to say, and this function, get team season statistics, given a URL, will return you in this solutions a list of lists where the first element in the nested list is the player, and then the next 17 are all the numerical statistics for that player. And I didn't really care about labeling things, so I didn't do a dictionary. I just know that, for example, element 2 is the number of at-bats, and element 14 is the batting average for that player. And so running it very simply will then print out the median batting average, which was all we asked for parts 1, 2, and 3. And then we go back to the assignment. And if you want to spend some time later on this evening or later in the week, if you're interested, in the solutions, I walk through the other instructions, which are to download all the data for the Yankees from 2002 through 2011 and print out the median batting average for each season and tell us which player had the best batting average in each season. And you'll see that the same names seem to come up a lot. And then also, in each season, what was the team's ratio of stolen bases to stolen base attempts? And then finally, to take it one step even further to its logical conclusion, download all the data for all the teams from 2002 through 2011 and figure out, based on all the players' batting averages, what the distribution of batting averages is like, and fit it with a Gaussian. So this is just more of the solutions, and then here is the histogram and Gaussian you should get. So over, I guess, 10 years, a decade of baseball, the batting average, the average batting average, is 0.239. And it doesn't fit a Gaussian too well. But these are humans, and they're usually not so normal.
People on the right are probably not all that.
Yeah, they probably have few at-bats. If you wanted to be very good about this, you would crop out outliers who have fewer numbers of at-bats and things like that. Okay, so the next part of the lecture, and we're still in talking to computers, which we'll be wrapping up in the next few slides. But quickly, I wanted to introduce you to JSON, which is JavaScript object. I don't know what the N is for. Paul, do you know what the N is for? JavaScript object. Anyway. Okay. Well, it is what I think is the best case scenario for if you want to talk to another computer. And here is the example. So if you remember bighugelabs.com, that was a website which offered thesaurus lookup with synonyms and rhyming stuff, etc. And this is what the web page looks up. So you would type in something like hamburger, and then it will return to you nouns and then rhymes, etc. Whoa, that's a lot of rhymes for hamburger. And what's cool about this website is it's mostly just an example website, but what's cool is this API. And I've read through all this, but all you really have to know is you need an API key, and then it will send you back query information as dictionary structures, like already. You don't have to parse it. You get it back as a Pythonic structure, well, as a JSON structure, which Python has a built-in library called JSON, JSON, to give you access to it. So define a base domain here, and then an API key. And basically, this is what you append to the URL down here in URL in order for the website to acknowledge that you have permission to use the API. And they do this generally so that they can track who is making calls. API is Application Programmer Interface. And so this allows the server to track how many times a specific key is being used, so that if somebody's using it too much, they can know who's using it too much and talk to you and say, come on, you're using the service too much. Or they can charge you based on number of times you access the service if it's a subscription type of thing. Yeah? So I did it just by emailing him, I think, or asking him. It's not that big a deal if you use it, because it's something like 10,000 times a day before he starts caring for this site. And so basically, we call, the guts of it is this line right here, where we call json.load, and then we give it the full URL. And here, because of the way the API is defined in here, this is the URL he wants you to use with a get, where it's just API and then the version and the key and then the word you want to look up and then the format you want to get it back in. And so here we want to look up dog, for example, and the format we want to use is JSON. And I guess version is 2 because that's just what it was when I looked this up. So run it, and there it is. We have all the verbs that are synonyms for dog, and then later on we have nouns that are synonyms with dog, etc. And oh yeah. Okay. So in the next example here, we print it a little bit more cleanly. We take advantage of it being a dictionary. So here we can actually separate things out and label them and make it more human readable. Because up here, just printing a dictionary, not so much fun to look at. But down here, it makes more sense, right? And we do this a little bit smartly also by checking for errors. So if I had asked for instead of dog but arg, that's not in there. So it can then therefore catch that and print it out as an error. So it knows to do that. Whereas if we had done arg up here, I wonder what will happen. We get a different type of error, and it's not so helpful, just a 404. So this is also showing you how you can read into the dictionary. You should all be able to write this up pretty easily based on the first example. But I wanted to give you a little bit of a head start if you wanted to use this type of thing in later on. So not all that many websites support this. I will give you some examples of APIs that are out there at the end of both of the lectures today. And you can, if you want to kind of tool around in there and learn some more about APIs, The short of it is that this is almost the easiest way to access information off of a web server in Python. Guys. Okay, we're almost done with the first part. The last part to show you of talking with computers is the famed XML RPC. So pay attention, because this will help you with your homework. It is, I think of it as a better TCP socket and client protocol. It's a different protocol, and it's better because it allows you to, where do I get to this? It allows you to include functions. So, is there anything important on this side? Right. So you can essentially have a function running on the server, and the client says, I want you to run this function with this input, and the server does the actual computations for the client and then returns the output of the function. So as you would write a function in Python with def, foo, and then input, and then do something to the input and then return it, that same thing is written on the server side, and then it sends back the return to the client. So everything is executed on the server side. So if you have a really clunky client, or if you, for example, have a specifically designed server machine to run this function, you can do things a lot quickly and have the right libraries accessible to be used on the server, which may not necessarily be installed or compatible or available for the client, and things like that. And it's XML because it uses XML for the transmission in the guts of it. But you don't have to worry about that because that's all hidden within the Python modules. This is the doc string just for completion, and then to the notebook to show you the examples. So if you recall how we did the TCP client and server, I'll be doing the same kind of dual window thing sort of going on here to show you them both going at once. And first we'll talk about the server. So here it is. So import the module simple XML RPC server, and then we want to define a class. And this is the class of objects that we want to expose to the client. And in this class, we'll define, just for example purposes, two functions. One we'll call addition, which just returns the two arguments a plus b, and one we'll call subtraction, which returns the two arguments a minus b. And we'll do it on port, let's do it on port 5020. And then, let's see, let me expand this a little bit. There we go. We create the server by using the simple XML RPC server within just the primary function of the module, and give it the host and the port, which is, you've seen how we've done that before, and then register the instance, which is to basically tell your local machine to start running it, and then to register the functions, which are going to be addition and subtraction, as well as multi-call functions means, are the two functions that you've defined, and then register introspection functions is a way to expose standard functions which you don't have to explicitly write, but which will be supported for the client. And you can expand upon them, and I'll show you when we take a look at the client. So let's start this up. And there we are. Oh, I wanted to start it here so that we could write out first that it's starting on port 5020, and then I'll call serve forever. Because just as with the TCP server, when I call serve forever, it will require an interrupt to stop it. So there we go, and it's busy. So now we have the server running on port 5020. So here we'll make this port 5020. And then to connect to the server, we call XML RPC lib.serverproxy and give it the host and the port within this sort of URL string. And list methods we're going to call in order to generate a list of the available methods. And server.system.listMethods is one of those introspection methods that we instantiated, that we registered purposefully. If we had not done this line before we started the server, we wouldn't be able to call this server.system.listMethods. And this is very helpful because it tells the client what servers are available and also prints out documentation for them, or gives them accessible documentation for those functions. So you can have an XML RPC server without giving the client a priori information about the functions that are supported. The client can interactively ask the server, hey, what functions do you have? And hey, what is the documentation for those functions, without the client knowing those, or the person writing the client knowing those ahead of time. And that'll be part of the homework. So then in the client, we're just going to list all the methods, print them out, and then we're going to run a subtraction call and an addition call and print the results from those things. So there we go. So the functions available are addition and subtraction, and then the system.list methods, method help, method signature, and system.multicall. Those are the multicall and introspection functions that we registered in the server explicitly. And just for fun, let's see if we did A plus B. Yeah, cool. And so it's agnostic to data type, the way that we wrote it on the server. So if you give it strings, it'll just add the strings together. And then, so this client will be able to run, or this client will be able to connect to the server indefinitely with calls like this. You can do server.any type of function on it until you decide over here to close it up, and we'll do that with an interrupt again. And then when it gets the interrupt, it prints out some errors. You've interrupted me. So it's a keyboard interrupt. Your homework is going to be basically to write half of a client-server pair. And what will be interesting about it is you won't, if you're writing the client, you won't know what the functions are until you query them through Python, because we're going to not allow you to talk to each other. We'll get to that at the end of the lecture, though. So I believe that's it for all the first 3 notebooks. That's the end of the first part of Interacting 1. So I'll close that up and start up Interacting 2. So that means you can go ahead and drop the client's notebook and the server's notebook. Let me just find, where do we have, where did I put this? Yeah. Lead page, there we go. Okay. So the next part of the lecture is going to be, how do we use Python to talk with not just computers, but people and hardware in the real world. And this is probably most useful to you in automating email access and retrieval, but I'll also demonstrate how to do some hardware, and as part of the homework, and just because it's cool, I'll show you how you can manipulate, record, and save audio files in Python. Okay. So the outline is, first we're going to talk about email, which are contained in the modules smtp lib, email, poplib, imaplib, and rfc822. And then I'll talk about how you can communicate with hardware that you can connect to your computer with a demonstration using a serial port, or in this case, because no one has serial ports anymore, I'll use the USB to serial connector, and then show you some hardware and show you how to do that pretty quickly, pretty easily. And then at the end, I'll do some demonstration and walk you through some examples of using audio recording modules, and show you how to do some recording and analysis in preparation for life, and because it's cool, and for your homework too. Probably motivation for you comes from the homework. So email is really, really simple, which is great, through these libraries. And here, I'm going to walk you through, basically, how we set up a simple mail transfer program or script in Python. I have provided for you an example email script in the weekly lecture files. And what I'm going to be showing is a little bit different here, but in the future, use that to figure out how you want to automate emails, because it's so easy, and I've done it for you, and you can just change your username and password, and that's pretty much all you have to do, in addition to specifying the server that you're connecting to. All right, so we import smtplib, and we create and we import a mine multipart, which is the format that you would write the email in, so you can make attachments to it. And then we'll create a message, and a message has specific dictionary keys in it, essentially, with a from and a to and attachments. So we specify who it's coming from and who it's going to, and it's important to get those right. And for examples here, I'm just going to be using example email addresses. So these are not real email. Well, these are not email addresses that I have credentials for. And then what's kind of important to note about smtlib.smtp is when you specify the server, the outgoing email server, you have to give it this 587, which is the number you want to give it for Gmail. And I believe this is the socket encryption method, or where to look for the socket encryption. And so this is the default that Gmail uses. But if you're using something like CalMail or some other type of email service, you have to look up this number for that, because it changes. There's a standard, but for various reasons, servers will use different values there. Right, TLS authentication, there it is. Okay, so, and then start the authentication, which is just start TLS, and then log in with your email address, your from address, and your password, and then just send the mail. And that's it. And here is the email example code that I provide you with, and I do it here just so it's color-coded so you can see it. It's defining a function, essentially, for you to use. So if you copy and paste this import and this function into anything you want to send emails in, you can then just mail and then give it a sender, a password, a to, a subject, text, and any attachments, and you can send emails. So I use this in my research to notify me of when something goes wrong. I can get an email from the program that's monitoring it that says, hey, something is going wrong at the telescope, you should take a look at it. And it's great because I am generally always in email contact, and this is one of the easiest ways to contact a human from a program running somewhere else, especially with smartphones and such these days. Speaking of smartphones, if you wanted to, you could also email a text message to an email address. So many carriers have forwarding, so if you give it a code in the email address with your phone number, it'll send the message as a text message. And that's another way you could consider getting up-to-date information from your Python programs. Okay, so sending is a little bit easier than retrieval. For retrieval, there's two methods, pop and IMAP. And first, I'll talk about pop. And you import poplib, string, string.io, and RFC822, which is a module that you'll also need to use, I believe, what do we use that for? There it is, to read the message properly. So first connect to the server, and we're going to use the Gmail pop server, and you need to give it 995, kind of like you had to give the 587 for the authentication. Give it a username and a password using server.user and server.pass underscore, and then you can request a list of all of the unread messages on the server. So pop method most easily gives you all the unread messages. IMAP will give you everything on the mailbox on the server. So if you wanted to download everything, you would use IMAP, but for many people that's way too much bandwidth or information that they care about. You only want the stuff that hasn't been seen yet. So with server.list, you can see the unread messages that are on the server that haven't been pushed out yet. And then here, we just parse them, we loop through them, and create printouts of the messages. At the end, make sure to quit the server. There it is. Retrieves only unread messages. Okay. So IMAP is very similar, except you're going to be using IMAP with SSL. And again, it's a little bit different, but the number is 993 for Gmail this time. Log in with the similar username password syntax, and then select the mailbox you want to use. In this case, it's just a generic, assuming you only have one mailbox, it's connecting to that default mailbox. And then return all the messages on the server with server.search, none, all. And then, just to make it easy, I reverse, in this example, all the messages such that we see them from the most recent date. And then loop through them and print them out. Yep. And in this case, it's server.logout instead of server.quit. So you could imagine that you may want to have an email address that only Python reads, or that only some program that you're writing in Python to read. Instead of your actual human email address, you might set up a specific email address for your script to check if you wanted to have it communicate with other things, or if you wanted to be able to send actual text emails that you write to your program to send information to it. It's a way of interacting with it, essentially.
Is this because you have a bunch of text files out there with your password doing plain text?
For the encryption?
Well, no, the script there, I mean, I'm sure it's encrypting it once you've written the script and when it's talking to the server, but the script that actually does anything useful for you has your password sitting in it in a text file, right?
That's true. So you're asking...
That file is readable, that if anybody has access to that file, then they have access to your password.
That would be true, but you can call the function without reading the file, I believe. I don't know what instance you're asking about, though. What application?
Security.
Yeah, so if you can read the file, you can read the password, yeah. Yeah, so be careful if you're writing in your password into these types of things. I generally just use it with my non-personal stuff. But at the same time, you can restrict read access to the file. So you can make it executable but not readable. I'm sure that's not totally bulletproof, but it's a step you can take.
It must be some encryption for it as well. I'm not sure.
Well, in the script, it has to know the... I mean, if there's a code, you can write it, and there's a code that's being decoded.
So yeah, so that's one. There is, I was just trying to look it up, I forget what it is, but there is a, I forget what it's called, but there's like a raw input that's non-echoing. So you could, for example, a slightly more secure way is to have it prompt you every time that you start running the script for what the password is. Password equals get raw. Get raw, though, will echo to the screen whatever it is that you type in. Now that's a problem if anyone's sort of shoulder surfing, they see the thing. There's a get raw equivalent that's non-echoing. I just forget where it lives. But there is something like that you can type in that will make it more secure. So now it's only in memory. So you type it, so you run the script and then it prompts you for the password just once. You type it in and then it'll pull all the messages. And then an alternative that I use, so this IMAP lib has been sort of extended to a whole package called offline IMAP. And so it's a Python-based thing that will pull. So the difference, IMAP is a two-way protocol, right? You can pull messages down, mark them up as read, and then next time you sync, next time you have an internet connection, it'll mark them as being read. So that's very useful. And what I do there to store my password is I store my password in a file on an encrypted thing, on an encrypted partition that times out. So it'll time out every half hour or something if it's not being used. If I'm not checking my email every half hour, then that file's been removed and then I get an error about it.
All right. Thank you. All right. So I'm going to quickly talk a little bit about how you can talk to hardware. There are a lot of different, basically for any connection on your computer, there is a Python module or several that have been written to allow you to communicate over it. For USB, there's PyUSB. For serial, there's PySerial. For parallel port, there's PyParallel. And for Bluetooth, you can do stuff like LightBlue and PyBlues, which is a little bit cool for transmitting files. And like if you wanted to access your phone, Bluetooth stuff, you could use PyBlues. But the compatibility is highly OS dependent because when we start getting into hardware things, we start getting into having to actually talk with the OS, and OSs deal with it differently. So, for example, PyBlues might be expecting an OS which is Mac, but won't work on Windows because it knows to look for the Bluetooth libraries and interfaces in the Mac OS, but doesn't know where to look for it in Windows, for example. Okay, I am going to give you a demonstration of PySerial. So to the terminal. Let me find where this is. Here we go. And do we have a terminal up? Where is my terminal? Here's my terminal. Okay. Bring that over there. We're going to make those a little bit smaller. Okay. So I've written here just a very brief code, and I've constructed a little LED next to a serial port, and then a little adapter which turns the serial port into exposed leads. And using PySerial and a driver for the USB to serial connector, I can then have control over the LED. Okay? So I can turn it on or off, and I'll walk you through first the function which does that. So,
You want to do your video camera?
well, I will show it first like this, and then I'll put it up on the screen. It's just because I can't do both at once. The screen is very small. But if you want to kill the lights, I mean,
If it's going to be lighting up.
yeah, it will light up. You should be able to see it. I'll also put it up on the photo booth in a little bit.
It's already working.
When we get my camera phone out.
Okay, so this code is called Morse code. You have it in your materials if you want to take a look at it without being dependent upon where I'm scrolling. But basically, we are defining a message, and then we're creating a serial connection with just serial.serial. And then this is the device ID. And here, I can even... So ls/dev, these are all the devices on here. And the driver for the USB to serial connector has the OS know that device/tty.usb serial. Yes. Is the address of the device. So it's the address of this blue serial connector. And then this is really just a way of exposing the leads in the serial. And then here I'm taking from green for ground and red for digital 0 for the leads to set the voltage on here. And I'm going to be able to turn on the LED just by turning on the digital voltage, and then turn it off by turning it off. And I've just written a really super simple script here which allows us to open it, turn on the LED for a certain amount of time, and then turn it off for a certain amount of time, which lets you encode Morse code, essentially, right? So let me run it. Well, actually, let me open up so that people, those 700 people, can see. Okay, that's cool. Yeah. There we go. So that is what the device looks like. That's a 1,000 ohm resistor, just a Astor standard LED. And then let me see, here it is. I'm going to need to get access to this. Okay. And we type in a message like Python rules. And then, when I return, you'll be able to see the light go off. Okay, so that just blinked out Python rules, and just to be cute, I put the data right. And so it was very simple. I'm going to show you again. It was just, we created the serial connection, and then I wrote this function blink, which is where it's actually done. So we go back up to blink, to turn on the light, we just set, what is the digital, there we go, data terminal ready status. So if we turn it on, we're essentially just turning on the voltage here. And then time it with the time module. And so for a dot, we'll do it for 1/4 of a second. And for a dash, it's 1/2 a second. And basically, blink just interprets whether it's a space, which is between words, or whether it's a dot or a dash, and then enforces the Morse code in the light. So let's run it again. And I was inspired by Morse code. By ABBA. And then as part of the printout, I just have it on the right there, tell you what the letters translate into Morse code. The translation is just performed by a dictionary, which was super simple because I could just say based on the key, which is the letter, or it also has some rudimentary like parentheses or question marks, and then translates it into Morse code and then carries out the Morse code on the LED. So this is just an example of some of the nifty things you can do once you can start interacting with hardware. If you do some searches for serial stuff in Python, there's a lot of Arduino hardware which people have experimented with, and they're very happy to tell you about what they've been learning about their hardware and PySerial and in very high detail, which is great because part of computer programming is learning from people who have done it before you. And there's a lot of that type of stuff for hardware interaction with Python. Anyway, so SOS is just the end. And the data rate, almost a byte per second. So a byte, where we're just assuming that a character is a byte, because generally in ASCII, that's how it is uncompressed. Okay, can we get the lights back? Oh yeah, and this was email example. Okay, so we don't need this anymore at all. Very good. Okay, so this is the final section that we're going to be doing today, and it is audio analysis, which is to impress you with the power of Python to, well, basically just to demonstrate that Python is very extensible. People have written lots of support for different types of hardware, as well as, in this case, microphone and audio analysis software. And in the homework, I'm going to ask you to reproduce some of the stuff that we're going to do here in order to identify notes. So here we have a wave file, which is the red plot. And if we analyze the frequency spectrum, we can find a peak, which is at about 600 hertz, which is D5 on the music scale. And so I'm going to walk you through some examples, basically introducing you to how audio is easily recorded based off either the line input on your computer, or I'll be using my microphone on the webcam. To the notebook. Here we are. Okay, so we're going to be using PyAudio in order to do our recording. And later on, we're going to be using Wave, which is a module, in order to write out to a WAV file. So it takes audio information you're going to learn is stored kind of interestingly. It's not just like storing notes and then times for playing the notes. It's actually storing the digital value as a function of time, and you can think of it sort of like the voltage that's driving the speaker. Okay, and so the chunk is going to be 1024, and then the rate is 44 kilohertz. And this is pretty standard stuff. Nothing here is too out of the ordinary. Channels, we just should do mono recording because that'll be simpler to analyze and use. More than one channel just records multiple arrays, essentially, side by side. depending on what types of microphone inputs you have. And then we create a Pi audio object, which we'll call P. And we're defining that we're going to save it to output.wave, but we won't use that until down here when we output it. And when we open the Pi audio object P, we give it the format and the channels and the rate and the frames per buffer, which is that chunk value, when we open it to instantiate it. And we have this stream now. And then in this for loop is where we start recording the stream. So for I in range starting from 0 and going until the rate divided by the chunk, we're going to write from the buffer the chunk of data that was recorded. Okay? So you could do it all in one chunk. You could do a super long chunk of audio, in this case 5 seconds of audio, and then just write it all at the end. But by doing it in a for loop, you allow it to change the number of seconds that's recorded independently of the chunk size, and you make sure that you never use too much of your buffer. So you don't want to go too crazy and record for hours and end up eating all of your RAM. So we'll say every 1024 bits of data, write it out from the buffer into the actual data object that we're storing it as, which in this case is just data. So we're calling it, yeah. So when did we make data? Okay. So I'm going to record, and then I will keep talking. So now as I'm talking, it is recording, and we'll be able to see the amplitude as a function of time when I plot it up. So it's done recording, so let's save it as a WAV file. And this is pretty much always the same. Just make sure that you have the same channels number and format and rate that you specified up above, because that's why we kind of specified it was to access it more than once. So accessing it the second time is rewrite the file, and then just write frames, and then close. And then if we go into my directory here, that's not what I recorded. Oh, this was from a different directory. This is the directory.
So now as I'm talking, it is recording.
There we go.
And we'll be able to see.
Okay, so now we can, where is this? Here we go. Now let's take a look at the spectrum. So there it is. That's my voice as I was talking to you. And it's just as a function of time, the amplitude. And to plot this up, it's really super simple matplotlib stuff. Anything interesting? Just taking, oh, the one interesting you've got to do is you've got to do this call for integer data. So from string, because it's stored as a string. And it's actually stored, I believe, as, well, let's take a look. Below, there we go. It's printing out a lot of, so it's taking a while because it's printing out so much. Yeah, it's stored as in bytecode. So this from string will convert the bytecode to an integer. And please take note of this for the homework, because you're gonna have byte strings which have to be translated into integers, and you'll do it using from string, and with the data type of 32. You can play around with that a bit and see how it changes things. I definitely encourage you to do that, but just be aware that that's one of the missteps if you're not paying too much attention. That can make it hard to do the homework. So I just plot it up like this. Okay, and so now to be super awesome, I wrote essentially the first part of this part of the homework, which is to identify a note, right? So audio demo, I'm not going to show you because it has homework solution sort of in it, but I'll run it for you. And when it finishes up, you can see I was whistling at about 1,000 hertz. So you can imagine if you played a chord with an instrument or a piano or an organ, tends to work well, you can then analyze it and figure out the notes. And that's the homework, is you're going to be given 12 samples of notes and asked to identify them by ingesting the data and then however you want. But I would strongly recommend you do a Fourier transform to figure out the powers of functional frequency and figure out which notes are the most important. Okay, let's go back to the lecture, and I believe, yeah. Okay, so the last point I want to make about interacting with the outside world with Python is that if you want to do something and you think that you're not the only one who wants to do that something with Python, probably other people have done it before you, which is awesome because then you can just use what they've done. And I think it feeds back into the overall community of Python programmers in that people make available the work that they've done to others, and then the others learn from it and also expand upon it and feed back into the system of shared code modules and things like that. And we encourage you to do that with the final project as one of the options there. So here's some list of some high-level interactions for specific applications. Facebook, Python Twitter, archive.py, stuff like that. And then also, I want to direct you to the GData Python client, which is a collection of APIs for Python into Google data. And so if you wanted to look up books or work with calendars, Google has written ways for you to do that through their system using a Python API to make it easy. And so, for example, here I believe is the calendar APIs with some information about that. If you wanted to add stuff to your calendar that you have on Google, you could do it through Python, for example. Okay. So let me flash up the homework and talk about that a little bit. Okay, so the homework is going to be two primary problems. The first problem is to write an XML RPC server client pair. So before you leave today, find somebody who you want to work with on this and decide who's going to be the server and who's going to be the client. And then the server's job is to offer 3 methods of providing lossless image manipulation. So you can write a method which is going to be something like take the image and for each pixel set it to a specific value based on the previous value of the pixel, or shift the image around, or magnify it and change it to be twice the size, things like that. But make sure you're not losing information so that you can document that method on the server using XML RPC documentation methods and then allow the client to read that documentation and then reverse engineer the function such that they can recover the original image. And so I don't want the person writing the client and the person writing the server to talk about what the functions do. So talk about the port number, talk about the IP address, work out a time to have it available, but don't tell them what image manipulation functions, what they accomplish. Have them do it, figure it out through list method, and then list help for the methods.
Is it valid to say it is accomplishing this function inside this image? This is even as consistently.
Yeah, but if you're doing that, you're overthinking it. You can totally do that, but make it easy on yourself. Do something like, I multiplied the pixel value by 0.5.
So you can say something like, you don't have to write your own, like if you want to rotate an image 90 degrees, you don't have to write something that rotates each bit. You can just say the image dot rotate.
Yes, you can do that, yeah. You can say this function just calls, yeah, I don't care. The point is not, you know how to manipulate images. The point is to get you to make an XML RPC server in client. So do not get stuck up on being complex with your image manipulation functions.
You could use the result of your last homework and have somebody send you an image and classify it.
And please, when you submit your homework assignment to me to grade, in your README, tell me who your pair was, who your partner was, so that I know I can have both of them open to make sure that things are going smoothly. Okay, the second part is the audio stuff. I have made up 12 sound files, which are not identified. They're just sound file 1, sound file 2, etc. And then 4 which are. And I want you to be able to write a program which can tell me what note is being played. And the sound files use different instruments, and sometimes, most of them are just one, but some of them are two, and some of them are 3 notes simultaneously. And you should be able to pick out which notes are being played and disentangle it from harmonics. Okay? So harmonic is like something which is twice as high in frequency. Would be if you played a 400 hertz note and you're also seeing a 200 or an 800, those are lower in power. So you should only look at the higher power in the frequency spectrum for those notes. And then hints, oh yeah. So this is probably what I already talked about. Use a Fourier transform and be careful about unpacking the string and hex code. Use 32-bit data, or at least I recorded the sounds as 32-bit data. So unpack it as mp.32, float 32. Is that all on the side? Yeah, beware of harmonics, yeah. Okay. So that's it for now. Find your partners, and if you want, get started on some stuff. Definitely, I would suggest you get started on figuring out a plan for the client and server stuff across that type of connection, either within the same computer or across a network. And then we're going to have the breakout exercise, which is to teach you about how to automate access to websites and then parse using Beautiful Soup or whatever you want, really, the information into more workable formats within Python. And that'll actually have to do with collecting baseball statistics. And then for the final part of the first part of today's lecture, I'll be talking about XML RPC servers and clients, which you should pay a lot of attention to because that's going to be part of the homework assignment, is creating an XML RPC server client pair. And I think it's one of the best ways to communicate between 2 computers both running Python, and hopefully I can convince you of that as well. Notably, it exposes functions on the server side that the client can call, which are executed on the server side. And that has some significant benefits if your client, for example, is on a really slow computer. Okay, so before I get started into websites and web servers, I just want to make sure that everybody's on the same page about how computers talk to each other. So in transmission control protocol, you have IP sockets. And most of the network communication is on TCP across the local area network, or as you go onto the internet. And there's also UDP, which we're not going to talk about too much, but you can support that in Python as well. And here's a diagram to basically show how data is sent. And I think the most important part to look at, there we go, is this is kind of like a schematic diagram of how you send information through TCP from one computer to another. And it's addressed by the MAC address, and then the IP address, and then the port number, and then the actual information. Okay? So what we're only going to be seeing really is the IP address and the port number in our examples today. You don't have to worry too much about the MAC address, but the MAC address is kind of like a more stable identification for a computer. So whereas IP addresses can be static, most commonly they're dynamic. So when you see DHCP, that's dynamic IP addresses. And so, for example, AirBears assigns you a dynamic IP address. But if you have a hardline Ethernet connection and you set your computer to use a static IP address, then you can always know what your IP address is, which is very useful, for example, if you wanted to connect to it from the outside network. You'll know the address to get into it. But anyway, okay. So let's get back to the presentation. So I want to give a brief overview of hypertext transfer protocol. And basically, when we transmit information over TCP/IP sockets, and the standard is port 80. So when URLib2 is calling out for this, it's doing it over port 80 by default. And if you wanted to create a TCP/IP socket server or client, and just stay away from port 80 because your web browser is going to be looking to use that. And there are basically reserved ports, and you can find lists of them. And of course, you can modify them on your computer, but other servers and clients expect to use specific, port numbers for specific services sometimes. So generally, if you're above 5,000, and you can arbitrarily define them, you're going to be OK. And so all the examples I'll be using later are 5,000 and up for port numbers. HTTP is used to transmit resources, and so resources can be files, query results, or server-side script output. And here's a Here's a diagram basically showing how the HTTP request is formatted and schematically transmitted from the client to the server. So the client basically sends a request with some header information and then the body, and then obviously the server reads it and then sends a response with response header information and then a response body. The two most used request methods are GET and POST. So I'm going to just move on to the next slide where we talk about GET and POST. And this is going to define basically, so it's going to define how you append additional information onto the URL. So what we did in that first example was just access a web page. But if we wanted to access a web page and send up additional information, for example, to fill out a form, if we wanted to make a query or have it run something with information that the client provides, you're going to do that either through GET or POST. So GET is the most common and the most generic form of sending up query information. And it is basically writing the query variables into the URL. And I'll show you that explicitly in the next example. I think that's pretty much all you're going to have to know for today's lecture. We're also going to be seeing a lot of this data here. And this can be almost anything. In our examples, in the next few slides, it's going to be HTML code, essentially. OK, so you use a URL. You guys probably know this to access a website and retrieve information. But why would you want to do this? Well, if you want to mine data, which is what we're going to do in the breakout exercise, you want to be able to easily access websites and pull down the data. You kind of did that when you were naming bears, if you did the first homework assignment, homework 0. And I will demonstrate in an example how we do that a little bit more efficiently now that we know more. You can use web address URLs to submit information to another system, to the server from your client. Or if you wrote the server, obviously, you could support that. And access web services. And so if you wanted to have a server do some crunching for you, you can do that through a web address through the interactions I'm going to be describing in the next few slides. And in particular, this is the type of thing that XML-RPC servers support more easily, let's say. More simply for you to code up than having to actually write a full web server type thing. OK. So here I'm going to start talking about the nitty-gritties of the modules that we're going to be using early on. And they are essentially the built-in URL lib and URL lib2, which are the libraries for URL access. And URL lib is kind of like the earlier one. It was written with not as higher functionality as URL lib2, which is better for more complex interactions and can handle authentication, cookies, and some more higher level things. And I'll talk about authentication, not so much cookies, in the examples in the notebooks. And they basically make calls to HTTP lib and HTTP lib2. They import those modules within them. And for example, this is just at the bottom. Where did my cursor go? URL lib open URL and URL lib2 open URL, you should use the second version. That's what we'll be doing today. But they are both still there, and eventually this one will be eliminated. And I just wanted to make you aware of that. So the doc strings, this is just to make sure that we have that information out there. You can read it if you.
He's got a bunch of notebooks that were written in the version that we basically instantiated for the boot camp. The new notebook, like as of like a week ago, we'll be able to read those old versions of the notebook files, and it will say when you first open it up, I notice this is an older version, I've just converted it. I hope that's okay, and that should be all right. There's a chance that if you've been pulling over from GitHub the notebook, or just IPython in general, and you haven't done it recently, that it won't recognize these old notebooks. But you should be probably okay. All right.
Okay. Yeah, so there's a lot of files to grab. It's all under lectures, and it's just one zip file. And then the homework has also been posted, but you don't have to worry about that yet. I'll be giving some more information about that later and showing a little bit of what you're going to be doing with the homework. It should be fun. So today's lecture is about how to interact first with computers in Python, and then in the second part of the lecture I'll be talking about how to interact with hardware and people. And so it's just a cartoon here of Python, and then it's got arms grafted on to show that now it can communicate, and then R2D2 is the computer, obviously, because it's a computer. So in this first part of lecture today, I'm going to first be talking about how to talk with web servers and websites, and the important Python modules we're going to be using are the built-in stuff, urllib, urllib2, ftplib, httplib, and httplib2. However, we're also going to be doing some parsing of HTML with HTML5lib and Beautiful Soup, and you probably don't have Beautiful Soup right now, so just run the command. Well, I guess the cursor doesn't work. So just run the command easy install Beautiful Soup 4, and you should be able to get that and have access to it within your Python installation.
Or pip install.
Oh yeah, either way. This will be very useful later on for the breakout, so you should definitely get it, and hopefully you'll be persuaded that it's way more awesome than doing it by hand. And I'll show you parsing stuff later on. Also in this first part of the lecture, I'll be talking about transmission control protocol, TCP, and creating sockets and clients, socket servers and clients that you can send information if you want to just by typing help in IPython, but we'll skip through this type of stuff. The most important thing that I want to highlight, obviously, because I've highlighted it, is that it returns a file-like object. So when we read a URL address with these libraries, we're going to get a Python structure that is handled like a file. So you read it like a file, and you have to close it out if you want to be proper to close it like a file. OK, so let's get to some examples. Yes. So talking to computers, so I kind of numbered them to try and make it easy. So talking to computers, which is number 1, and this is going to be what we're going to be focusing on until we get to the client-server stuff, which is 2 and 3. You probably already saw that. So this is just a super simple web page access. And I'm going to import urllib2, and then define a URL, which is just the string for some web page, and then open it with urllib2 open URL. And then, as I mentioned, the response here is a file-like object, and then I can read it and store the data in what I'm calling HTML, and then close it out because we're proper and we like to close things so that we don't screw with memory too much. And then I'm only printing the first 300 characters because it's really long. And you can run it, and there it is. So are there any questions with that? It's
you want to maybe open up that in a different tab, the actual URL, and then do
yeah.
and then show the source?
Oh, to verify. We can prove to you that that's actually what it shows. So this is what it looks like, rendered in a browser. And then if you check out the source, where is it? View source. You could see, so for example, the first 300 of these, probably cuts off around here, is what we had here. So title, neuroscience information framework, and then you see that same title in the source in Safari, right there. So you should be aware, I guess I'll say this right now, many websites hide some of what their stuff's doing, and it's not explicit in the HTML. So if you've got Flash or some JavaScript plugins, there can be information that you can read in the browser which are not really present in the HTML. And you won't be able to access that, at least not through this urllib2 open URL function. We're not going to worry too much about that. Those are kind of difficult to script.